All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving some questions on fundamental physics chapter 6, that is rotation of rigid bodies. And this first question says we should write down the three equations of motion, three equations of linear motion, and the equivalent equation in the rotational motion, right? This is very simple to write. So what do? Draw a line, and then you have here is linear motion, and here is a rotational motion. Please, if today is your first day of watching my video, please click on that red subscribe button and give this video a thumbs up, a like, so that YouTube will recommend it to others. All right, I have a full video on um, circular motion and rotation of rigid bodies. All right, so this particular video is just for calculations. We're going to be doing calculations. So the first equation of motion, don't forget, is what? That V is equal to what? U plus AT. So you will now change it for rotational motion. This is linear velocity. So you change it to what? Angular velocity is equal to what? Initial angular velocity plus what? Angular acceleration times your time. Very simple. So the second one is what? That V squared is equal to U squared plus 2AS. So change it. You have what? W squared is equal to omega squared is equal to what? Omega 0 squared plus what? 2A. Then this is your theta. Okay, very simple. So the next one, which is the last one, say them that number 3, say that S is equal to UT plus half AT squared, which is what? Theta is equal to what? U is what? Angular 0 T plus what? 1 over 2 alpha T squared. So that is that for that. Now let's now solve this question. This question now said that what? A body rotates at a speed of, they have given us the first initial angular velocity, which is what? Omega naught is equal to what? 1200 rav revolution per what? Per minute. Now we can change it into what? To rad per second. Okay, you can change it to rad per second, or you leave it in revolution per second. So changing it to revolution per second, you have 1200 divided by 60, so which will give you 1200 divided by 60. 1200 divided by 60. So I have 20. So I'm having here as what? 20 revolution per minute. Right? So the next one is we have what else do we have? The second one. Okay. So the next one I'm going to have is what else? So the next one I'm going to have, or we can decide to change it to a rad per second, because the SI unit is rad per second. So changing revolution, one complete revolution per second. One complete revolution is 2 pi. So this is what? Multiply this thing by 2 pi. I'm going to have what? In fact, let me change it direct. So changing it direct, I'm going to have this is equal to 1200. Changing revolution, one complete revolution is what? Is 2 pi. Okay, now divided by what? Changing minute to second, you have 60. So this is what? 40 rad now. Rad per sec. So 40 pi rad per sec. Okay, 40 pi rad per sec. So the next one is they gave us increases the speed to this. So they gave us our W now, which is the final angular velocity, which is what? 3000 revolution per minute. So which is what? 3000 times changing revolution to rad to radian is what? Times complete circle, which is 2 pi. 2 times 180 in terms of angle, that is 360. But that we're not using 180 here. I'm just trying to tell you that how the 2 pi came about. Divided by 60 is equal to what? This is 100 pi rad per sec. Okay, so that is that. So the next thing we have to calculate is okay, they gave us time. They said that the time here is what? 12 seconds. Okay, now what else now? Then I say I, that we should calculate the what? The angular acceleration. Now from the equations of motion, we can get our angular acceleration from here. From here, we know that what, that our W is equal to W naught plus what, alpha t. So what do we have? Our W naught will give you, this is 100 pi is equal to what, 40 pi plus alpha, alpha times 12. So this one coming here will have what, that 12 alpha is equal to 100 pi minus 40 pi. So I'm going to have that 12 alpha is equal to 60 pi. Okay, so therefore my alpha will now be what, um 60 pi divided by 12, which will give you 60 divided by 12. We're going to have 5. So I have what, 5 pi then rad per second square. Okay, so this is times 3.142. Okay, so now if you want to, you can decide to get your answer. If you don't want to use pi, you now put 5 times 3.142 to get your last answer if you don't want to use pi. So this is something I'm saying, the same thing here. So this is something I'm saying, what, 5 times 3.142 then rad per second square. If you don't want to put the pi, which will give you, I think, 15.71, approximately 16 rad per second square. All right, so that is that. Now the next thing they say, we should calculate II. We should calculate the number of revolution made by the body. Now to calculate the number of revolution, now we can decide to use let's get our theta. Okay, if we want to get our theta now, we can say that theta, I can decide to use this. I can decide to use this, or I can use this. Anyone will give me the same answer. So I have that what, W squared is equal to what, W0 squared plus 2 alpha theta. I'm looking for my theta. So now we now have that here is what, 100 pi all squared is equal to what, 40 pi all squared plus what, 2 times I'm having okay, let me use 5 pi here. 2 times 5 pi, okay, then theta. So what do I have here now? I'm going to have that this time this will give you 10 pi theta is equal to what, 100 pi squared minus this. That is, let me say 100 squared minus 40 squared. Hope you know, because this one will come here to have 100 double zero pi squared minus 16 double zero pi squared. That is this one coming here, or let me write it the way you understand it. First of all, I'll have this squared will give you 100 pi squared is equal to what, 1600 pi squared then plus 10 pi theta. Okay, this one can now come here. So permit me to clean here because I'm done with this question. So I'm now having that 10 pi theta is equal to, this one can now move here to have 100 pi squared minus 1600 pi squared. So therefore 10 pi theta is equal to this minus this will give you 8400 pi squared. So therefore my theta will now be what, 8400 pi squared divided by what, 10 pi. So I'm left that my theta is equal to what, this take care of this, I have what, 840 pi. Okay, this, since there is pi in it, I'm going to use what, revolution. Okay, since there is pi in it, I'm going to use revolution. But I know that a complete circle, a complete revolution is what, that is 2 pi will give me complete revolution. Okay, so therefore I'm going to divide this thing by 2 to get the number of revolution. So the number of revolution is equal to what, the number of revolution will now be what, that is 840 divided by 2. Don't forget that there is pi here, rav, so which will give you what, 420. That is 420, that's the number of revolution. Okay, so that is that for that. So, or rather, we can say that if you don't want to have it that way, we can say that that you can do your cross multiply. You can say that 2 pi at one revolution is equal to what? 2 pi. Okay, since one revolution is equal to 2 pi, we will now have that what am I saying? So how many revolution will give you this one that I've already gotten? So how many revolution will give you 840 pi? So if you cross multiply, you now see that what? That 2n pi will now give you what? 840 pi. So therefore, n will now be what? 840 pi divided by 2 pi. So that's how we got what? 420. So the number of revolution will now be what? 420. Very, very simple. So we go to the next question. Okay. If you like, you can do it in radian by, instead of using pi, just change your pi to 3.142. You still get the same result. So question number two. So question number two said calculate the angular speed. Calculate the angular speed of I, the second hand of a watch. I, the minute hand of a watch. Okay, so this is very, very simple. So each time you are asked to calculate the second hand of a watch or the minute hand of a watch, is very, very simple. So you're going to say that solution, we are looking for W. We know that W is equal to 2 pi f. Don't forget that 2 pi f, and don't forget that our f is equal to 1 over t. Okay, so if you put 1 over t here, you now see that W is equal to what? 2 pi over t. Okay, so 2 pi over t. Now the first question for I said the second hand of a watch. The second hand of a watch means that t is going to be 60. So I'm going to have that W is equal to what? 2 pi over 60, which is what? 2 times 3.142 divided by 60. So if you do that, you're going to have 0.10 rad per sec. So you can calculate that. 2 times 3.142 times 2 divided by 60. 3.142 times 2 and divided by 60. So I'm having 0.0 rad per second. So the second one now, they say the minute hand. The minute hand, I. The minute hand means 2 pi divided by, now if they are talking about minute, you say 60 times another 60. So I'm going to have what? 60 times 60. Okay, if they say hour, put another times 60. So I'm going to have what? 2 times 3.142 divided by 60 times 60. So I'm going to have divided by another 60. So I'm going to have 1.7 times 10 raised to power minus 3 in what? In rad per second. So that is that for that. So go to the next question. This one is very, very simple. Okay. So the next question, question number three. Question number three said that the angular position of a point, on the rim of a rotating turntable is given by theta is equal to 4t minus 3t squared plus t cubed. Then say calculate the average acceleration of the turntable. Average acceleration of the turntable for the interval t is equal to 2 seconds to t is equal to 4 seconds. Okay, So now this is very, very simple. So what do we do? Now don't forget that solution. Okay. Now, first of all, if you are asked to find the velocity, okay, you should know that the angular velocity is equal to what? Change in distance over what? Change in time. Okay. But don't forget that what? Angular acceleration is equal to what? Change in the velocity over what? Change in time. Okay. So now, but if you want to go uh, okay, now if you want to bring in this one inside here, you will now see that this thing is equal to what? Change in the t. Instead of writing w, don't forget that w means another dt over dt. So this is going to be the second derivative. So that's why we have this time is to give you d squared theta over what? Dt squared. You get? So that is the formula to use. That alpha is equal to what? Dt theta over dt squared. Now what does it mean? Differentiate two times. So the first one, the first differentiation will give you our W, or let me just say the first differentiation will give you our W. Our W is equal to what? The theta over what? The T, which is equal to, differentiate 4T, you have 4. Differentiate this one, multiply by the power, remove 1 from the power, we're going to have minus 6T. Multiply by the power, remove 1 from the power, I'm going to have plus 3t squared. So the second derivative means differentiate this one. So differentiation of a constant is 0. Differentiation of minus 6t will give you minus 6. Differentiation of plus 3t squared will give you plus 6t, because you multiply by the power and then you remove 1 from the power. So then I gave you the interval, the range. So now for the interval, I'm going to put my t to be 4, and then put my t to be 2, and then we get our final answer. So when t is 4 and then when t is 2, very, very simple. So now, first of all, now at my t is equal to 2 seconds, I'm going to have that my alpha is equal to minus 6 plus 6 into 2. So which is minus 6 plus 12, which is equal to what? 6 rad per second square. So now, when t is now 4 seconds, so we're going to have that alpha is equal to minus 6 plus 6 into 4, okay, which will give you 24 minus 6. I'm going to have 18. So I'm going to have 18 rad per second square. So that is that for that. So what do we do now? The interval now subtract. They say from here to here. Okay. So since we say from here to here, so you now say your ending point alpha for 4 minus alpha for 2, which is what? 18 minus what? 6. And 18 minus 6 will give you what? 12 rad per second square. So from here to here. So this is where we ended minus where we started from. So the answer is what? 12 rad per second square. So we'll go to the next question. Question number 4. So for question number 4 said the angular acceleration of a rotating body is given by alpha is equal to 4a t cube. Let me write, is given by alpha is equal to 4a t cube, okay, plus 2bt. Then I say where t is time and a and b are constants. Now say if the wheel has an initial angular speed w0 written, okay, sorry, w0, they don't say comma, they don't say write the equation for I question, now say the angular speed I don't say the angular displacement as a function of time. Okay, as a function of time. Okay, so now this is very very simple. So what do we do? Watch out. So now let's bring out what they gave us. They gave us alpha. They said that alpha is equal to 4 4 4a, okay, 4a t cube plus 2b t. Now the first question say we should calculate the angular speed. Now do you know that acceleration is what? Change in velocity over what? Change in time. Now if you are going back now to get this person, you integrate. I get what I'm saying. If you're going back, to get, if you have W and you want to get this person, you differentiate. So since you have this person, you want to get W now, you integrate. So therefore, my W will now be what? The integral of now this person, starting from 0 to t. Okay. So now what do we have? This is equal to now the integral of you now put here 4at cube plus 2 dt. Sorry, 2 what am I saying? 2bt dt. Okay, how do I get the dt? Cross multiply here to have that. This is the w is equal to what? Alpha dt. So if you now integrate both of them, you now see that differentiation is opposite of integration. So to get this w will now be the integral of alpha dt. So that's how I got this. Okay, so it's very very simple to get. So now let us integrate from 0 to t. So integration means, remember that in differentiation what we did was multiply by the power, then remove one from the power. In integration, what you do is what? Add one to the power, divide by the new power. So you are doing the opposite of differentiation. Differentiation said multiply by the power, remove one from the power. You see, so but integration now say add one to the power, divide by the new power. So I'm going to say if I add one here, it's going to be 4at 3 plus 1 divided by that same 3 plus 1. So add 1 to the power, divide by the same power. So I'm going to have plus, the t means I'm differentiating with respect to t. So I'm talking about this t. So I'm saying 2b t starting alone means t raised power 1. I will say plus another 1. I've added 1 to the power and divide by the same power. You see, it's very very simple. So I'm going to have 4a t raised power 4 over 4 plus what? 2b t raised power 2 over 2. Don't forget there is a boundary. My boundary is from 0 to t. So I'm putting my boundary from 0 to t. So I'm going to have this, take care of this. I have what? at4, okay, plus this, take care of this. I have bt2. Okay, so now the boundary said, sorry, not 4 but t. The boundary said substitute the one up minus substitute the one down. If I substitute t, I'm going to get the same thing. If I substitute 0, I'm going to get 0. So anything minus 0 is the same thing. So that is why my final answer is this. But maybe this is 3 and 2. Then if you see t, put your 3 minus. If you now see, you now put your 2, that kind of thing. Then you now subtract and get your final answer. So this is my final answer now. Now, from this one gotten, permit me to clean here. They say we should calculate the angular displacement. Permit me to clean here. Now, to get my angular displacement, I know that my w is equal to what? Change in angular displacement over change in time. Okay, if I cross multiply like I taught you now, say that the theta will now be what? W dt. So if I now integrate both sides, if I now put integral to the both sides, differentiation is opposite of integration. So I'm left with theta is now the integral of my w dt. Okay, so which is what? I've gotten my w. So therefore my theta is now what? The integral of w dt, which is what? The integral of at4 plus what? bt2. Don't forget that is from 0 to my t. Okay, so what do I have left? We now have that okay, so this is equal to what? Don't forget, add 1 to the power, divide by the new power. So I'll say at raised power 4 plus 1 divided by the same 4 plus 1 plus b raised power t raised power 2 plus 1 all over 2 plus 1. So I'm going to have at raised power 5 over 5 plus bt raised power 3 over 3. Don't forget that my boundary is from 0 to t, but if you substitute, you will get the same thing because anything minus 0 is still the same thing. Okay, but if it is not 0, don't forget to substitute. As simple as that. Right? So any other question? Let's move to the next question. So the next question, um okay, all right, okay. There is something I forgot to let you know, and it is simply sorry. They said we should calculate the what we are asked to calculate was what? They say calculate the, where is that question again? They say calculate, write down the equation for the angular speed. Okay. There is something we missed, and what we missed was to add the initial speed. So the W here is supposed to be what? W0 plus this answer gotten, please. It's supposed to be, my, this is supposed to be W0 first. W0 plus the integral of alpha dt. Okay, so that's the what I just skipped. So just say that W here is equal to W0 plus what you are doing. So just be adding W0 plus, you understand, W0 plus so this is W0 plus my, okay, let me just add it here. So W will now be what? W0 plus. So that is that. So for the other one, all right. So we move to the next question. The same is applicable here. Don't forget that I'm going to have W0 plus all these things. So this is going to be W0 plus everything here. Okay. So that is that for that. So here is going to be W0T, W0T plus everything here. Okay, so that is that. So just know that for the distance we're going to add W0T, but for the W we're going to have just W there. Okay, so we'll go to the next question. I forgot the initials, so that is why it was like that. So let's go to question number 5. For question number 5 question number 5 said an object of mass 8.0 kg is wheeled round a vertical circle of radius 12 meter at a constant speed of 6 meter per second. Then say calculate the maximum and the minimum tensions in the string. Okay, calculate the maximum and the minimum tension in the string. That is question number 5. So to do that is very very simple. So you know that solution, you should know that the force is same as tension. Force is same as what? Tension. And formula for tension is what do we do? Okay, now let me quickly tell you why we had that WT there. Okay, let me just, before we continue with this, we should know that I told you that alpha, that to get your W is equal to W0 plus the integral of alpha t from 0 to t. Okay, now we now got that W0 plus, when we did everything here, we got we got a t raised to power 4 plus bt squared. Okay, now when we are getting this means just the integral of everybody here. Integral of w0 plus what? at4 plus bt this dt sorry, alpha dt here. So dt, so which is what? The integral of w0, the integral of a constant means to bring in the variable. Okay, if you have the integral of 2 dx, this is a constant, it's going to be 2x because this is opposite of this, so I'm left with this 2. So to differentiate this person that is a constant, okay, this is opposite of this. Differentiation is opposite of integration, so I'm having the w, so I'm having w0t. So that's how w0t came. So differentiation these people, we know what we got finally. I think we got this is a t raised to power 5 over 5 plus b t raised to power 3 over 3. So that's how the wt came about. I just started to show you now. Okay, that's what I missed. Okay, so we know that tension is equal to force, and which is what? Mv squared over r. Very simple formula. So let us now put it. So this is equal to what? My m. So let us put everybody to have so what are we putting for the minimum? Okay, let's talk about the maximum. The maximum is that we are taking the whole radius, everybody. So we are taking the whole radius for the maximum. Okay, for radius for maximum is what? 12 meter. But the radius for minimum is what? Half of the maximum. 12 divided by 2, which is what? 6 meter. So just put everybody in your formula. So the tension for the maximum will now be my m is 8 times my v. Where is my v? The speed, 6 squared divided by, for maximum I'm having 12. So if you do everything there, you're going to be having 36 times 8 divided by 12. So I'm having 24 newton. Okay, but for f minimum is going to be what? 8 times what? 6 squared divided by 6. So I'm going to have 8 times 6 squared divided by 6. 8 8 8 times 36 divided by 6. So I have, huh? Sorry, what am I saying? Tension for the minimum. Tension for the minimum. Am I having tension for the minimum supposed to be smaller than this? It's supposed to be half of this, half of tension of the maximum. So this is going to be times 2, not divided by 2. So it's going to be 12 times 2, which is this is 24. Because it's supposed to be half of the tension here. So I'm going to have 24 here. Okay. So it's going to be what? So 8 uh, times 8 times 36 divided by 24. Sorry, 8 times 36 divided by 24. Aha, 12 newton. So just get, what you do is just get the tension for the maximum, divide it by t, you get the tension for the minimum. Okay, instead of wasting your time and racking your brain and trying to get what you don't know how to get. So go to the next question. Question number, I think question number 6. Now for question number 6, we have that if a force F is equal to 2I plus 3J minus 7K, okay, acts on a particle at position R, which is equal to 4I minus J plus 8K. Then I say calculate the torque exerted on the particle. Is it on the particle about the origin? Okay, now this is very, very simple solution. First of all, you should know whether torque is a vector quantity or a scalar quantity. right? That's the first thing you should know, if it's a vector quantity or a scalar quantity. But tau is a vector quantity, so since this is a vector quantity, we know that tau is equal to what? The force times the perpendicular distance. uh, and I'm using cross product. I didn't use dot product because it's a vector quantity. So you do your metrics. So I have my plus I minus j plus k. So for f, I'm going to have 2, 3 minus 7. For this, I'm going to have 4 minus 1 and 8. So now you pick your plus I, open bracket, close this place. I am left with 1, 2, 3, 4, because everybody here is just for picking. You do your left minus your right. So 3 times 8 is 24, minus this time this will give you 7, because minus minus is plus. 7 times 1 is 7. I'm done with this. I'm picking my minus j. If I pick my minus j, I'm covering here. So I'm left with 2 minus 7, 4 and 8. Do your left minus right. 2 times this is what? 8, minus this time this will give you minus 24 again, right? 24. So I'm going to have another minus 24. Then finally I'm picking my plus k. If I pick my plus k, I'm covering here, say left minus right. So this time this will give you minus 2, minus this time this will give you 12. Okay. So what's the next thing? Sorry, 4 times 7 is 28. 4 times 7 is 28. Okay, so I'm now left with what? 24 minus 7. Where is my? I think I have calculator here. 24 minus 7. I'm going to have 17i. So I have 17i. Okay, then 8 plus 28. I'm going to have 36. So minus 36j. Then I have minus 14k. Okay, so now having this, so the next thing you do, this is the tau, but to get the newton, to get it in you don't want to get it in dimension. Okay, so what you just get is their maximum, their magnitude. Just get their magnitude. Okay, so that is that. So what did I do here? When I closed this, sorry, 2 times 8 is 16. This is 16. So 16 plus this will give you 16 plus 28 will give you, okay, 44. So here is 44. That's a mistake, sorry. Okay, so I have 17i minus 44j minus 14k. So to get the magnitude will now be the square root of what? 17 squared plus minus 44 squared plus minus 14 squared. So I'm going to have, if you do everything there, you're going to get 49.2 Newton meter. Okay, so that is that for that. Very, very simple. So we move to the next question, question number 7. For question number 7, I have question number 7 say state the theorem of parallel axis. Okay, please state it for me at the comment section. The theorem of parallel axis, state it for me at the comment section. So the calculation here said a uniform disc has a mass of 4 kg and a radius of 2 meter. Then I say calculate the moment of I, calculate the moment of inertia, calculate the moment of inertia about an axis perpendicular to its plane I through the center II through a point at its circumference. Okay, so want to calculate the moment of inertia about this axis. So what do? First of all, we should know the formula for moment of inertia. But before that, we have to bring out our parameters. So the moment of inertia about an object. So the moment of inertia of an object about an axis is the measure of resistance to change the angular speed. Okay, so uh, right. So what did they give us? They gave us the mass. Let me see the question again. Question number 7. Okay. All right. Mm, mm, mm. I think there is an error here. Okay. We know that moment of inertia solution. Moment of inertia is equal to what? Ma squared over 2. I think I'm having issue. First of all, let me bring out my parameters. The first thing they gave me was the mass. The mass is 4 kg. Okay. So the next thing they gave me is the radius. The radius they gave me is 2 meter. Okay. Then I say we should calculate the moment of inertia. Now the moment of inertia is equal to what? Ma squared over 2. So which is what? Or mr squared over 2. Let me use mr squared over 2. So I'm going to have that my m is 4. I have r squared, which is 2 squared over 2, which is 16 divided by 2, which is what? 8 what? 8 kilogram meter square. Okay. So the next one, question number okay, then I say the other one is about a point. Where is the point? That's the problem now. Where is the point? About a point on the circumference. They're supposed to give us that particular point on the circumference. That's the problem I'm having for this particular question. This one is at the center. That's why we have over 2. Okay, but at a particular point, well, we don't know the particular point. So how do we do that now? Okay, if I have I want to check something. 24. So if I have 16 okay, about a particular point, I think we did an experiment on that. Yes, I think I remember that the moment of inertia about a particular point on the axis, I think should be 3 r squared over 2, something like this. I think yes. About a particular point, you use this. I'm going to have 3 times my m. My m is 4 times my r 2 squared divided by 2. So I'm going to have 3 times 16 divided by 2, which is what? 3 times 8, 3 times 8, which is what? Yes, 24 kilogram meter square. So about a particular point on the circumference, use this, but for the middle, we use this. Okay. So don't forget the formula, please. Don't forget the formula, please. All right. Or you say after getting about the middle, you multiply by 3. So it will be easier for you. Okay. So moment of inertia about any particular point is equal to what? The one about the middle times 3. Okay. So don't forget that. So let's go to question number 8. So for question number 8, let me check if my time is even going. Okay. So for question number 8 said, what is meant by moment of inertia of an object about any axis? Tell me that on the comment section. Then say, how can you measure the moment of inertia of a metal disc? Tell me that on the comment section. I'm here for calculation. So this one said that a cylindrical solid of density P, which is equal to 20 gram per centimeter cube, whose whose length and radius are respectively 200 cm and 25 cm. Okay, is rolled downhill at a speed of 300 cm per sec. Then I say calculate I, the moment of inertia of the solid. Okay, so I'm going to have I say the kinetic energy of translation, I the kinetic energy of rotation of the solid. Okay, so now from here, let us write out what we are given. Okay, first of all, we are given the density and we are given the mass. They say that the density P, is equal to what? 20 gram per cm cube. Okay, were we given the mass? This is cm, not km. So were we given the mass? The mass is not given. Are we given the volume? No, but we can calculate the volume. We know formula for the volume. So the volume of the cylinder can be gotten as 2 pi L plus R. Okay, 2 pi L plus R. That's how to get the radius. So, and I want my radius to be in cm. So since this one is in cm, let me not stress myself. So I'm going to have this is equal to 2 times 3.142 in bracket of 200, the length, plus what? 25. So I'm going to have 225 times 3.142, then times 2. Okay, so this one gave me 413.9 cm cube. Okay, so the next thing it's 2 pi r. This is not correct. 2 pi r, then yes, 2 pi r, then L over r. Yes, sorry, the volume, no, volume is cube, so I checked that I used 2 cm, so it cannot give us cube. So it's what? 2 pi r first, then r plus L. This is very, very correct, because cm will give you cm cube. So I have 2 times 3.142 times my r, my radius is 25. They gave us radius to be 25, and they gave us the length to be 200. So I have 25 into 25 plus 200. Okay, so do that now. This is supposed to be correct. So 3.142 times 2 times 25 times 225. So I'm having 35347.5 cm cube. Okay, so now for us to get the mass, now we know that density is equal to what? Mass over volume. So to get the mass is what? Density times volume. So which is what? The density they gave me is 20 times the volume. I got the volume as 35347.5. So if you multiply it by 20 times 20 to get my mass, so the mass there is what? 706,950 in gram. Why is it gram? Because this is in gram, so it's gram. So to convert it to kilogram, and then can get our moment of inertia. So to convert it to kilogram is by dividing by 1000. So if I divide by 1000, So this is going to be 706.950 kilogram. So that is that. So now, so if you have gotten your mass, so what else is remaining if you have gotten your mass? So what did they give us as this? 20, okay? So if you have gotten your mass, you will now know that moment of inertia is given by what? Mr squared over 2, right? Mr squared over 2, which is what? My M is 706.950 times my R squared. My R squared. Now, the problem now is that for the R, I cannot use cm now for the R. You convert it to meter. So converting cm to meter is divided by 100. So I'm going to use 25 divided by 100. So I'm going to use 0.25. So 0.25 all squared now divided by 2. So you have squared then times 706.95 now divided by 2. So I'm having 22.09 in kilogram meter squared. Okay, so that is that. But if you are going to make mistake while calculating it, you can decide to convert everybody. Okay, so now the next thing we are asked to calculate is the kinetic energy. I know that kinetic energy, I kinetic energy is equal to what? Half mv squared. Okay, so where is our velocity? So the speed here is 300 cm per second square. So if you now change it to meter per second square, you are going to have say calculate what? The kinetic energy of translation. Kinetic energy of translation is half mv square, which is what? 1 over 2 times my m is 706.95 times my v squared. Convert this one to meter per second. So just divide this by 100. Okay, that is 300 divided by 100, which is what? 3 meter per second. So that is that. So multiply by 3. So that is multiply by 3 squared. So if you do that, you're going to have that is 9 times 706. 9 times 706.95 divided by 2. So I'm having 3181.275 joules. Okay, so that is that. So now, for us to calculate the III, so to calculate the kinetic energy of rotation, I'm going to use the kinetic energy. Kinetic energy of rotation is what? 1 over 2 moment of inertia, then have w squared. Okay, so which will give you, that is kinetic energy of rotation. For kinetic energy of rotation, so do that to get your answer. But for w, we don't have w here, so but we know that that v is equal to war. There is war when you have velocity. We use velocity to do war. So wr, v is equal to wr. So if you now have that, your w will now be what? V over r. So you have that kinetic energy will now be 1 over 2 moment of inertia, v squared over r squared. Okay, or v over r all squared, anyone you like. So put in your parameter because I've wiped the board. So put in those parameters we have, then you now get your answer. So let's move to question number 9. Okay, velocity war. Sometimes I used to confuse that w is equal to vr or v is equal to wr. Okay, but I now said that with you fight war with velocity, so velocity is equal to war. But in my war, the a will be missing. So war is WAR. So but A should be missing. So this is how I used to remember that V is equal to WR. So in case you are like me, that always forgets formula, You just find something to be remembering the formula. So question number 9, which is the last question I'm going to solve here. Question number 9 is said 2 points 2 point masses of M1 is equal to 20 kg, okay, and M2 is equal to 15 kg, and held 50 cm apart. Okay, then I say calculate the moment of inertia. Calculate the moment of inertia. One, about an axis passing through M1, II, about an axis passing through 10 cm from M1. Okay, so to calculate the moment of inertia about an axis passing, so let us get our parameter first of all. Solution, they gave us our M1 to be 20 kg, our M2 to be 15 kg, so, and our R, the distance apart, R is equal to what they give us? 50 cm, which is 0.5 meters. That is divided by 100. Okay, 0.5 meters. Now, so the moment of inertia of M1, is equal to what? The summation of M_R squared, M1 R squared. So, but forget the summation. The summation, you're going to have that. So do that. You're going to have my M is what? 20 times 0.5 all squared. So if you do that, you're going to have 20 times 0.5 all squared. I'm going to have 0.5 squared times 20. So I'm going to have 5. Okay, so I'm going to have 5. What do you say we should calculate? The moment of inertia about this. 20 times 0. Is there a mistake somewhere? Yeah, I'm getting 5. I'm getting 5. What did they get? They got 3.75. So what is the error there? Let me check. R1 squared. Is R our distance separating them? Yes, R is supposed to be the distance separating them. So what is the problem about passing through this? If it's passing through this, then the summation of this from 0 to this will now be, I think there is an error somewhere. Where is the error? Times 15. It's passing through M1, but it will get to M2. Okay, so this is supposed to be, sorry. So this is supposed to be the summation. So this is supposed to be the summation of MR squared. Okay, so I'm going to have my M1 R1 squared plus M2 R2 squared. Okay, so this is going to be my M1. My M1 is 20 times my R1 should be 0. So that is from 0. My R1 is 0. My R2 is this. So this is 0 squared plus my M2 is 15 times my R2 is 0.5 all squared. I think I've gotten the correct thing to do. Yes, because that's why it's at summation. So I'm going to have this is equal to 0 plus do this. I'm going to have 0.5 squared times 15. I'm going to have 3.75. So this will give you 3.75 kilogram meter squared. So that is that for that. So we'll go to question number 9b, the last question here. Oh, sorry. The other one said passing through 10 cm. So the one that is passing through 10 cm, I'm going to have from that 10 cm to our our MO2. Okay. 10 cm, passing through 10 cm. Let me check. Passing through 10 cm. 25. Okay. Where is it? Passing through 10 cm. Where is it? So what do they get for that thing? 2.6. Okay. Since it's passing through 10 cm, they want to say passing through M1. My, let me check something. Let's see. If it's passing through 10 cm, it's passing through 10 cm. I think I'm going to have you can try that and give me the answer in the comment section. I'm trying to get confused. But maybe we'll look at that and then I'll drop the solution at the comment section. I don't want to get confused, I beg. Question number 9b. 9b. 9b said the system if the system of the masses completes 5 revolution every 10 seconds, then I say calculate the total kinetic energy of the system in each axis. Okay, so to calculate the kinetic energy, don't forget that kinetic energy is equal to what? 1 over 2 moments of inertia W squared. Okay, so and you don't forget that our W is equal to what? For every raf per sec, our W is always raf per sec. So 5 over 10 raf at the top, revolution on top, then seconds below. So this divided by this will give 0.5 raf per sec. So now, if you put it here, you're going to have so put it there. You're going to have what you got for moment of inertia in the other one, you use it. What you get for what you get as moment for the first one, the one that is passing through M1, the one that is passing through M1 will give you 1 over 2. We got 3.75, so times 3.75 times 0.5 all squared. So it will now help you to get. So if you now calculate the other one, you will not get what the other one is. So this one will now give me 18.52 joules. So for the other one, you know what to get for the other one. So that is that. But before that, this is revolution, but we're supposed to change it to a radian per second. So I told you that this is 2 radian, 2 revolutions. So it's going to be 2 times this. 0.25, 0.5 times 2. So 0.5 times 2. This is 2 times 0.5 rad now per sec. Or you put pi in it. So 2 pi times 0.5 rad per sec. Okay, which will give you just pi rad per sec. So let me use that here. So 1 over 2 times, instead of using this, I'm going to use pi squared. So which will give you 3.75 times 22 over 7 all squared. So if you do that, because this one is the revolution per sec, So you need to change it to rad per sec so that you can get this one in joules. So thank you very much for watching. Don't forget to like the video, comment so that YouTube can spread it. Bye bye. If there's any error, please comment at the comment section.